Okay, geometric series, they're important enough that we're going to look at a couple more problems with them. So let's take a look. Let's consider the following sequences. So k goes from 1 to infinity. We start with 3/4 to the k. We're also going to look at negative 3/4 to the k. Yes, geometric series, they don't need to be all the same sign. They could be alternating signs. Okay, let's look at instead of 3/4, let's look at 4/3. And let's also look at negative 4/3. Okay, let me put those up here. Because why? Because these are both divergent. Okay. The ones where the r or whatever it is your geometric rate is bigger than 1, they're divergent. Doesn't matter if they're negative or positive, divergent. Okay. Now this one. This one follows just the same pattern we had before. Okay. So this is going to be our r equals 3/4. This is going to be 1. Oh, let me make this from 0. Why do I change those? Those don't matter. But let's move from 0 so that my first term is 1 over 1 minus 3/4. 1 over 1/4 looks to be 4. Okay? Now, what happens here? Here, our r is actually negative 3/4. So, we're going to have to take that into account. 1 plus 3/4 is 7/4. So that's going to be 4/7. Okay? So it's slightly different. And what's going on is that here we have some positive, some negative. It's still going to converge though. Okay? All right. Couple other nice things. Let's take a look at repeating decimals. Okay. Let's take a look at, let's say, 0.27 repeated. Maybe that one's a little too hard. Take a look at 0.9 repeated. All right. We'll do the other one later. So that's 0.9999 going on forever. Okay. Now this is where you have to understand what the decimal represents. This represents 9 over 10. This represents 9 over 100. This represents 9 over 1,000. Okay, so we're getting this repeating decimal. That's this sort of series. Well, let's pull out a 9. Because they all have a 9 there. Okay, Now we have a geometric series. This is from 1 to infinity, 1/10 to the k. All right, I can pull out the 1/10. I can, like I normally do. I guess you guys don't know that, but that's how I've been doing it. But what I'm going to do is let's use the first term divided by 1 minus the ratio. So 9 times 1/10, that's the first term, times 1 over 1 minus 1/10. So 9 over 10 times 1 over 9 over 10 is 1. So 0.9999 repeating is equal to 1, formally. Okay, let's try another one. Let's try that other one we were going to do, 0.27. Okay, that means we have 2727, 2727 repeating, right? Okay, so that's 27 over 100. That's this, right? Okay, well, let's do it a little bit. Let's do it as 2 over 10 plus 7 over 100 plus 2 over 1,000 plus 7 over 10,000. Okay, now these I could put together to be 100, right? 27 over 100. These I can put together to be 27 over 10,000. Now 10,000 though is 100 squared. I want you to keep that in mind. Okay, and you can sort of see where it's going. So 27, let's pull out the 100 this time. 1 plus 1 over 100 squared. Okay, so this is 27 over 100, running out of space. Let me make some more space for myself. 1 over 1 minus 1 over 100. Okay, 1 minus 1 over 100, 99 over 100. (27 over 99). That's a fraction. Actually, we can reduce it. We can reduce that to what? 9 over 33 divided by 3 is 9 over 33, and divided by 9, 3 over 11. Calculate 3 over 11. Tell me if, damn, you don't get 0.27 repeating. Okay? All right. I'll see you all in the next video.